Now we'll see an example how we are going to create a Hebbian network to implement OR functions with bipolar inputs and outputs. So we are having the OR gate with x1 and x2 values. Along with this we have one input that is related to the bias value, that is x0, which is always set to 1. And we have the target value associated with every input that is given to the OR gate. Now what we have to do is we have to calculate the weight adjustment, and we have to find out the updated weights for every set of input vectors. So first we are going to initialize the weights and bias to 0, that is W1, W2 and B is set to 0. That is the first step. Next what you have to do now, you have to take the first input, that is x1 is equal to 1, x2 is equal to 1 and y is equal to 1, that is the target value. And the formula for calculating the delta x value is input into the target. So if we want to calculate delta x1, what is the input? That is 1. So 1 into the target is 1. So 1 into 1 is equal to 1. In the similar manner, you calculate the delta x2 value and b value with its corresponding input value of x2 and the corresponding input value of B. For B it is you have to take a del x0 value. So x0 value is 1 here in this case. So 1 into the target value is equal to 1, that is equal to 1. Okay, next we have to do, you have to do the updation of the weights. For updation of the weights we have to use this delta x value, and we have to add that value with the old weight value. So the old weights for W1, W2 and B is equal to 0. So we have to use those values. So when you want to update the weight W1, what is the weight, old weight W1 is equal to 0. So 0 plus this delta x1 value, that is equal to 1. So the updated weight W1 will be 1. In the similar manner, you calculate the updated weights for W2 and B. So after the first set of calculation is over, we are getting the updated weights, that is W1 is equal to 1, W2 is equal to 1 and B is equal to 1. So this is for the first input. In the similar manner, you have to calculate for the second input. For the second input, what is the input value? It is x1 is equal to 1, x2 is equal to minus 1, x0, that is that the input that is related to bias B is 1 and the target value is 0. And we have to use this updated weights which you have got it from the first step. That is W1 1, W2 1 and B equal to 1. So with this value you calculate the delta x1 value. So delta x1 value is equal to x1 is equal to 1. So 1 into this weight W1 value, that is 1 into 1 1. And when you come to here, the value corresponding input value for x2 is equal to minus 1. And what is the target value? It is 1. So 1 into minus 1, that is equal to 1. And del B value, when you calculate, it is x0 value is equal to 1 and target is equal to 1. So 1 into 1, that is equal to 1. So we calculated x1, delta x2 and delta B. Now you update the weights. For updating weights, you take the old weight 1 into 1 plus 1. Here you are going to add the old weight plus the delta y. So this W1 is equal to 1 plus this value 1 plus 1 2. When you coming to W2, this is minus 1 plus this old value. So 1 plus minus 1, that is equal to 0. When you come to B, it is 1 and here also it is 1. So 1 plus 1 2. So the updated weights is W1 is equal to 1, W2 is equal to 0 and B is equal to 0. When you take the third input, x1 value is equal to minus 1 and x2 and B x0 is equal to 1 and target was also 1. So when you calculate delta x1, minus 1 into 1. So delta x1 is equal to minus 1. Delta x becomes 1 now here and delta B becomes 0. When you add this with the old weight is this 202. This you have to use it. So when you want to calculate the W1 or update W1 value, the 2 plus this minus 1. So you are getting 1. When you come to W2, this here you are getting 1. What is the old weight? Old weight was 0. So 0 plus 1, that is equal to 1. When you comes to B, what is the old value of B? That is 2. 2. This 2 plus this one. So 2 plus 1, 3. So the updated weights W1 is equal to 1, W2 is equal to 1, and B is equal to 3. And when you take the fourth input, all the three, x1 is equal to minus 1, x2 minus 1, x0 was 0, and then y is equal to minus 1. So when you calculate here minus 1 into minus 1, delta x1 becomes 1 and delta x2 also becomes 1. But delta b, that x0 value was 0. So 0 into minus 1 target, it is minus 1. So when you add these delta values with these weights, we are getting W1 is equal to 2, W2 is equal to 2, and B is equal to so. So this is the updated weight which you have got and which is considered as the weights that is going to give the correct input to the or gate. So this is how we have to implement. That is the implementation of Hebb network will help you to implement find the solutions for the R gate. Thank you for watching.